what you see on the screen right now is a matrix, and students generally have mixed opinions when it comes to matrices. Some find it confusing, others find it fascinating, and some see it both ways. By the end of this video, you will have a general understanding on what a matrix is, as well as get to know a couple types of matrices. This matrix in particular here is a 2 by 3 matrix, and a matrix is basically just a rectangular arrangement of numbers defined by rows and columns. Rows go across while columns go down, and in this case, so you define a matrix by rows first and then columns. So in this case, there are 2 rows and 3 columns. Therefore, it is a 2 by 3 matrix. Moving on to the types of matrices. So here we have a row matrix. A row matrix is basically a matrix with one row. In this case, the numbers 1, 2, 3 are on a single row, and the matrix is a 1 by 3 matrix, which means it has 1 row and 3 columns. Therefore, it is a row matrix. Following that, we have a column matrix. A column matrix now is a matrix with one column. In this case, we have the numbers 1, 2, 3 aligned vertically, which means it is a 3 by 1 matrix in the sense that it has 3 rows and 1 column, making it a column matrix. Following that, we have a rectangular matrix. Now, a rectangular matrix is formed when the number of rows is not equal to the number of columns. In the case of the matrix over here, we have a matrix with 2 rows and 3 columns, and it's a 2 by 3 matrix. And as you can tell, the number of rows is not equal to the number of columns, and therefore it is a rectangular matrix. A rectangular matrix could also be a matrix that is 3 by 2 in the sense that it would have 3 rows and 2 columns. And following that, we have what is known as a square matrix. A square matrix is where, unlike in the rectangular matrix where the number of rows are not equal to the number of columns, in a square matrix the number of rows are equal to the number of columns. And when you see this matrix over here, it's a 2 by 2 matrix, which means that there are 2 rows and 2 columns, and therefore it is a square matrix. Now, square matrices can also be 3 by 3 matrix or 4 by 4 matrix. It just has to have the same number of rows and columns. And following that, we have zero or null matrix, and this matrix is where all the elements in the matrix are 0. That is basically, there's nothing further to that. It's just a matrix where all the values in the matrix are 0. And moving on, we have a diagonal matrix where, as you can see here, there is the main diagonal, which is the numbers 2, 5, 1. And the matrix as a whole is a 3 by 3 matrix, but then we've got the diagonal 2, 5, 1, and outside the diagonal, as you can see, all the values are 0, all the numbers are 0. So basically what a diagonal matrix is that all the values outside the main diagonal are 0. And afterwards we have a scalar matrix. Now, a scalar matrix refers to a matrix where all the elements in a diagonal, in this case it's 3, 3, 3, all those elements are equal, they are the same value. So when all 3 elements or numbers in the main diagonal are of the same value, that matrix is known as a scalar matrix. And then we have an identity matrix. An identity matrix is where the main diagonal has the numbers 1. So in this case, it's a 3 by 3 identity matrix, and the main diagonal has the number 1 on it, and the rest of the numbers are 0. So it is also, an identity matrix is also denoted by an capital I. And then following that, we have an upper triangular matrix, which means that all the values below the main diagonal are 0. So when we have the upper triangular matrix, all the values you can see up here, they have integers above the value of 0, but anything below the main diagonal here is a 0, and that indicates that this is an upper triangular matrix. And then we have a lower triangular matrix, which is this one, and in a lower triangular matrix, all the elements above the main diagonal are 0 in comparison to where in the upper triangular matrix all the elements below the main diagonal are 0. So when we are speaking of the lower triangular matrix, where all the elements above the main diagonal are 0, you can see here the main diagonal is 1, 4, 6, and all the elements above it are 0, which makes it a lower triangular matrix. And then to conclude the types of matrices for now, we have the symmetric matrix, which I was going to get into it today, but I think I'm going to get into it in the next in one of the following videos, as I'm going to get into symmetric matrices as well as singular matrices and non-singular matrices, as those are related. You would need to know what a transpose and a determinant is to understand what a symmetric matrix, singular matrix, and non-singular matrix are. So I will get into it in the next video. Hope you understood something from this one.